Imagine gliding silently above the city in a sleek, futuristic craft. No exposed rotors, no emissions, just pure electric lift and effortless motion. Now imagine it costs only $5,000 and is already turning heads worldwide. A new wave of vertical flight is taking shape, promising personal air travel that blends compact design, advanced control systems, and high-speed performance. In this video, we explore the leap in aviation that's breaking every rule. In Israel, at the Megiddo Air Base, Urban Aeronautics presented test flights of its cutting-edge aerial machine called the Cormorant. This remote-controlled aircraft, capable of vertical launch and landing, is built for use in places where conventional helicopters cannot operate, owing to its special inward-facing propeller system that allows for flight within narrow and irregular areas. During the demonstrations, the Cormorant showed its capacity to autonomously perform an entire flight sequence, from takeoff through navigation, payload delivery, and return to origin. These experiments confirmed its usefulness in scenarios such as evacuating injured persons, transporting supplies, and entering zones that are dangerous or unreachable. It uses a Turbo-Mika Aerial 1 Delta turbine motor and can move loads of up to 500 kilograms across up to 300 kilometers. Its configuration ensures high agility and dependable flight control, as well as functionality within tight confines, making it ideal for civil and military purposes. Bellwether Industries, a London-based urban air mobility pioneer, has revealed its innovative eVTOL craft named the Volar. Revealed through newly released footage captured just days ago, this aircraft represents a fresh category of private city aircraft known as a Volar. The showcased model is a half-scale prototype, and its sleek, car-inspired form hides ducted fans beneath an aerodynamic shell. No exposed rotors, just a clean, futuristic profile. In the test footage, this scaled-down version, nicknamed Antelope, performs a fully untethered free flight in Dubai, climbing to an approximate height of 4 meters and accelerating to roughly 40 kilometers per hour under remote control. Though minor instabilities are visible, Bellwether confirms that these initial flights provide essential stability data, which will guide refinement of its flight control systems. Bellwether anticipates that the full-scale version of the Volar will accommodate 4 to 5 occupants, span approximately 3.2 meters in width, and deliver urban commute performance with a maximum speed near 217 kilometers per hour at altitudes around 915 meters. The envisioned flight endurance is between 60 and 90 minutes on a single battery charge, supporting true intracity air travel. Looking ahead, Bellwether aims to enter commercial production by the year 2028. With its compact, noise-reduced electric design, the Volar could make personal aerial commuting a mainstream reality within the next decade. A further significant leap in personal flying technology comes from the Czech firm UDX, which introduced the trailblazing Airwolf airborne motorcycle. This electrically operated vertical takeoff and landing aircraft carries 2 passengers and merges speed, responsiveness, and a futuristic look. The Airwolf utilizes 4 distinct electric engines with rotatable fans that provide agility similar to that of a hummingbird and enable top speeds of 230 kilometers an hour. Reaching 100 kilometers an hour from zero takes only 3 seconds. Its structure is composed of carbon-reinforced fiber, ensuring durability while keeping its mass at 290 kilograms. Built-in wings provide about half of the necessary lift, reducing battery strain and enhancing efficiency. Its airborne capacity is limited to 25 minutes, and it can travel up to 66 kilometers on one charge. Flying the Airwolf in the United States requires a sport pilot permit, which mandates 20 hours of aerial instruction. The vehicle's cost is estimated at $320,000 United States dollars. The aviation firm DTA aircraft manufacturer, based in France, showcased a novel electrically powered aircraft capable of vertical takeoff and landing, named the JP-1. Its introduction occurred during the international technology showcase GITEX Global, where its sleek appearance and potential for widespread flying vehicle use captured immediate interest. Thanks to advanced automatic piloting and stabilization mechanisms, the JP-1 is intended for use without formal pilot training or certification. It is completely battery-powered, making it an ecologically friendly solution tailored for travel within cities. Emitting no pollutants and operating with minimal sound, it is particularly well suited for crowded areas. The JP1 includes a sealed passenger compartment with upward opening see-through doors resembling those of sports vehicles, ensuring ease of entry. Its lightweight, streamlined structure enhances both safety and comfort while airborne. Jetpack Aviation has introduced an exceptional creation, the Speeder, recognized as the planet's first airborne motorcycle. This invention merges vertical liftoff and landing abilities with the maneuverability and compact size typical of a motorcycle, paving the way for new advancements in individual flight. The Speeder runs on 4 turbojet propulsion units that enable upward lift, stationary air positioning, and forward motion. A digitally controlled balance mechanism simplifies navigation, while laser-based LiDAR technology helps maintain steady hovering with minimal positional shift. The Speeder is built with modular and flexible design goals. Several formats are being developed, including piloted models, unmanned freight drones, and versions for defense usage. The Speeder can achieve velocities reaching 241 kilometers each hour and climb to altitudes nearing 4,572 meters. Depending on build and environmental factors, operational duration varies from 10 to 22 minutes. Top honors go to the engineers behind the Cavorite X7, the initial electric vertical takeoff and landing aircraft on the planet, to successfully perform a seamless transition from stationary lift to forward flight. Tucked within its retractable wings are 14 concealed fans that enable vertical ascent, similar to a multicopter or helicopter. However, once aloft, the fans withdraw, permitting the wings to operate like those of a standard fixed-wing aircraft. The flying machine then proceeds forward, using a turboprop engine paired with a rear-mounted propeller. This innovative setup results in an impressive peak velocity of 450 kilometers per hour and a journey range of 800 kilometers. It accommodates 6 individuals and offers operational expenses approximately 30% lower than a conventional helicopter. Currently, the Cavorite X7 is nearing completion of a full-scale, human-piloted demonstration unit. Nonetheless, the anticipated price has already been disclosed as $5 million United States dollars. Here's some positive news for this episode. In the month of April, the company completed a successful test of its Blackbird. Though it remains a reduced-scale model, its significance for both commercial potential and scientific progress is immense. This marks the planet's first electric vertical takeoff and landing craft to ascend using cyclorotors. Those large cylinders you see? Their outer surfaces are composed of movable vanes that continuously adapt to the surrounding airflow. What does this mean? Unlike traditional rotating blades that require time to build up force, cyclorotors respond almost immediately and can redirect thrust across a full 360-degree spectrum. Because of this, the Blackbird delivers exceptional maneuverability, even in challenging atmospheric conditions, and demonstrates the real-world promise of this technology. Cyclotech intends to introduce a production-ready version by the year 2035. It will be a 2-passenger vehicle with a maximum speed of 150 kilometers per hour, targeting elite private owners rather than mass consumers. Introducing 2 electric vertical takeoff and landing vehicles aimed at elevating urban transportation. The first, known as Volo City, is an airborne taxi built for 2 occupants. It is capable of traveling a distance of up to 20 kilometers and reaching a velocity of 100 kilometers per hour. In addition, metropolitan areas will benefit from their second, more spacious electric vertical takeoff and landing model, Volo Region. This version accommodates 4 travelers and is capable of covering distances as far as 100 kilometers. Its peak velocity surpasses that of the compact taxi, achieving up to 250 kilometers per hour. The manufacturers envision the Volo Region as a seamless transit solution, connecting city centers with neighboring residential zones. The engineers at Klein Vision, by contrast, are making remarkable strides. Their flying automobile, powered by a traditional internal combustion motor, is advancing toward full-scale manufacturing. The firm plans to construct 100 examples annually, with the initial model expected to reach the market by the year 2026. What renders this achievement especially notable is that the Klein Vision team comprises merely 7 members. Yet they have managed to develop a vehicle that competes with offerings from far larger industry leaders. Their second-generation air car converts in just 80 seconds, attains land speeds of up to 200 kilometers per hour, aerial speeds of 250 kilometers per hour, and delivers a flight range of 1,000 kilometers. However, the cost is significant, beginning at $800,000 United States dollars. The developers behind Gove took an unconventional approach by designing their vehicle to divide into two sections. The bottom half resembles a low-profile compact automobile, while the upper segment takes the form of a large-scale drone. If all progresses as planned, Gove will be arriving at doorsteps and soaring into the air by the year 2027. The creators have already received regulatory clearance for commercial aerial operation within China and intend to employ the Gove to link key metropolitan areas. Here are some of its primary specifications: an approximate aerial travel capacity of 200 kilometers, a sustained travel speed of 80 kilometers per hour, entirely electric propulsion, and the capability for vertical takeoff and landing. Would you consider boarding the Gove, or would you opt instead for the Switchblade? Tell us your thoughts in the comments. What if highways were not limited to the pavement beneath your tires, but extended to the open air above? Imagine this. You are driving along a motorway at 200 kilometers per hour. You arrive at an airfield, and within 3 minutes, your vehicle expands its wings and ascends into the sky, reaching a maximum velocity of 305 kilometers per hour. This is not a dream, but an actual machine with more than 2,000 confirmed reservations. Its name is Switchblade. This hybrid automobile bridges terrestrial and aerial travel and delivers a flying range of 724 kilometers. The anticipated retail cost is $170,000 United States dollars, and it is expected to become available by the beginning of the coming year. In a bold leap toward a science fiction future, Pete Beto and Carla Salif introduced the Leo Coupe, a sleek 3-seat flying car designed for vertical takeoff and landing. Powered by electric jet turbines, it blends innovation with practicality, launched in the year 2020 to transform urban mobility. Resembling an electric car more than a plane, the Leo Coupe fits in a 2-car garage, perfect for city use. Its all-electric system includes Defense Advanced Research Projects Agency funded propulsion for safety and efficiency. The minimalist cabin seats 3, with semi-autonomous controls and 5th-generation wireless connectivity. It reaches 250 miles per hour with over 1 hour of flight per full charge. Ideal for private use, taxis, emergencies, and remote areas. It builds on electric jet aircraft's JetAC platform. Recognized by the National Aeronautics and Space Administration for innovation, Leo Flight rapidly developed prototypes, including the LX-1 manned Alpha model, advancing toward a cleaner airborne future where flying cars become reality. If you enjoyed this glimpse into the future of personal flight, make sure to like, subscribe, and hit the bell so you never miss the next big leap in tech. More groundbreaking innovations are just around the corner. Stay tuned.